for us, it's about using the best science and the methods that are available, and then using it for the purpose that we need, which is right now to test solutions to combat the effects, or at least to adapt to the effects of climate change. Mm-hmm. And in a way, if you can combat it too and mitigate, your emissions, that's great, which is what a cool roof hopefully will allow us to look at.
Welcome to When Science Finds a Way, a podcast about the science changing the world. I'm Alisha Wainwright. And on this series, I'm talking to the global experts who are making a difference, as well as the people who have inspired and contributed to their work. Today, we're talking about a potential way to keep cool in extreme heat. We've talked about heat stress on this show before because it's a big challenge that affects all of us. As climate change causes temperatures to rise around the world, people are having to adapt to sweltering conditions that have serious health impacts. And many of the regions most vulnerable to extreme heat don't have access to resources and infrastructure that could mitigate the problem. For these places, the question is, in the face of rising temperatures, how do you keep cool in a way that's low cost, passive, and sustainable? Well, that's where today's guest comes in. Dr. Aditi Bunker is an environmental epidemiologist and leads the Climate Change and Health Intervention Unit at the Heidelberg Institute of Global Health at Heidelberg University. Aditi is also affiliated with the School of Population Health at the University of Auckland, New Zealand. Aditi and her team have led research into an intervention called a cool roof. A cool roof is a simple, effective tool that can help keep a home cool in extreme heat without needing ongoing maintenance or energy use. After a 2-year trial in Burkina Faso, they've expanded their research around the world. Today, we'll hear more about the potential impact of this solution, as well as how researchers collaborated with local communities to conduct the trial. And here and in person is Dr. Aditi Bunker. Thank you so much for joining us.
Hello, thank you for having me, Alisha.
Oh my gosh, thank you. I feel like all the stars aligned to bring you here to Los Angeles so that we can meet in person, and I am so glad. I wanted to ask about your area of research. You test interventions that help people adapt or mitigate the effects of climate change, and you study how those interventions lead to different population health outcomes. So what drew you to the field?
Well, I actually started my PhD in 2012, and this was actually based in Burkina Faso.
Really?
So, yes. So I got 1 million vaccinations and turned up there a few days later.
Your arm half swollen?
Yeah. With my yellow fever vaccine certificate.
Mm-hmm.
And turned up there, and then I basically haven't left. So I love the place. I love the people, the community there. Our Nuna Health Research Centre is integral to a lot of my work.
Wait, hang on. Before we jump into that, I want to be able to talk about what you're about to bring up, which is cool roofs, but we'll get to that later on. But first, I want to get some context about the location of your study, which you've mentioned, Burkina Faso, rural Burkina Faso. When we talk about extreme heat in a place like Burkina Faso, what exactly are we talking about? How hot does it get? And what are the kinds of problems that people face?
So Burkina Faso is in the Sahel Desert.
Okay.
And so they experience very dry kind of heat from about March until June. And then that's followed by a very heavy downpour and monsoon rain.
Awesome.
And that's when typically people are working in the field. And in the community where we work, there's a lot of people are subsistence farmers. And so that's where it's really interesting. So the people are in direct exposure and contact with the environment a lot there.
Right.
And it's well above 40, well, it's about 40 degrees and above 40 degrees Celsius. I think that's about 104 Fahrenheit.
That's hot, yeah. For consistent many days and into the nights as well, because I have discussed on a previous episode that it's the night heat, too, that can be problematic, as well as the day heat, because no one ever gets to cool down.
Yeah, that's right. So there is sustained heat well into the night. And so this kind of continuous exposure to heat can have detrimental health effects. That's right. So yeah, it's a challenge, and the housing conditions are, are quite basic in a lot of situations.
Can you run us through some of the health problems and challenges someone would face in these heat conditions?
Yes, so heat kind of affects our body in different ways. So it places strain on the heart. Your body wants to cool down, and so it's moving blood around to the periphery, and therefore your heart's working harder to pump blood to the core organs. You're feeling other sort of physical manifestations like tiredness and even things like anxiety can arise from heat stress. There's been evidence to show that suicide and aggression and things increase with heat. Even for chronic illnesses, there's links now with increasing diabetes, with renal health problems.
Wow.
And of course, there's heat stress. So things like dehydration and heat stress are all affected by heat.
Let's hear from Gninasse Rose. She lives in a village named Pa outside of Nuna in Burkina Faso. It's about 300 kilometers or 186 miles away from the capital, Ouagadougou. Life here is very different from the big city. This is a village in rural sub-Saharan Africa, a region that is especially vulnerable to the effects of climate change. Gninasse spoke to us about life in their village and the impact extreme heat had on their household.
Our daily activities are based on agriculture and housework. We collect wild fruits and we also farm. We have a primary school but no health facilities. We're 5 kilometers away from the health centre. Our house is a one-room house, not very big, with a tin roof and a cement floor. It's made of mud brick. I live there with my husband and 4 children. Extreme heat kept us awake. It's unbearable. It was unbearably hot inside during the heat, so we often slept outside. We took showers several times a day. The children cried and couldn't sleep. We couldn't stay inside with the babies, and it was impossible to put them to bed inside. We often had to use fans to ventilate the children, and often you would get up in the morning with your child and they would be too hot, and you would have to go to the health centre for treatment.
So, if you were living in a big city like Ouagadougou, you could just switch on the aircon or have an electric fan to cope with the heat, but that's not very realistic in a rural location, is it?
Yeah, you're absolutely right. So I think in the area where we work, in the Nuna Health and Demographic area, we have about 56 villages, and I think only 6 of those have access to electricity plus the Nuna Health Centre. And here people live typically in kind of a one-room home. So they have compounds, and within these compounds, the families kind of live together in their individual homes, and they're composed of the mud, the traditional adobe mud, and with kind of 4 walls, typically an outside cooking area, and the roofs traditionally used to also be mud brick. However, now there's a movement towards people selecting tin-roofed homes, which is really interesting.
Is it because it's cheaper, or it's like less destructible?
Well, actually, there's a couple of reasons. One is cultural, funnily enough. So people associate tin roofs with being wealthier.
Okay.
Kind of a higher socioeconomic
So it's a status thing, yeah.
And another reason is, I think mud brick roofs actually, they take quite a bit of maintenance. So there's a traditional practice every year where people go on top of their roofs and apply a sheer butter or a coating that kind of creates a waterproofing.
To deal with the monsoon season.
Exactly. So, so I think it's quite a lot of work. However, as we all know, the tin-roofed homes kind of become like ovens. Yeah, I mean, we went into the community and actually sought to understand, so that was a lot of our formative work before we started the trial, to understand how they actually perceived heat and what they thought of it, what sort of an impact. And it very much echoed the sentiments there that we just heard, that people were really affected in terms of their physical health. So things like tiredness, feeling dizzy, getting rashes on their body, lack of sleep, to social aspects, people having difficulty maintaining family harmony and intimacy.
Because everyone's irritable and want to stay 5 feet away.
Right, and mental health.
Yeah, of course. And sociability is a really important part of mental health. And if everyone's feeling irritable and cranky, it's kind of hard to be able to have that house harmony. So first things first, can you tell me what is a cool roof and how does it work?
Yes. So the type of cool roof that we used in Nuna, it's actually a paint with special kind of properties that make it highly reflective. And the idea is that it basically is something to cool down the indoor ambient temperature. And it works in two ways. The main kind of way that it works is by reflecting the solar radiation from the sun. And the other way that it works is it actually reduces the heat from being absorbed inside through high thermal emissivity. So those are kind of...
bounces off, basically.
That's right. So one of the ways is that it bounces off, and the other is that it stops the heat from actually being absorbed inside.
So what are the advantages of a cool roof when we're talking about mitigating extreme heat for people like Gninasse? And what are the immediate effects that someone would face living in that home?
Yeah, well, the effect of a cool roof is immediate. So that's one of the great things, we don't have to wait for a long time for there to be any sort of benefit. But it's basically something it's quick to apply. We can use the local people and community to do it. It's relatively cost effective. It can also last for a long time, depending on the quality of the material.
So it's not a annual reapplication.
No. Okay. Yeah. So it's got anywhere between a 3 to 10 year longevity.
Oh wow.
And so for our communities it's great. One of the biggest benefits I find is that it's a passive intervention.
Yeah.
That's what we need. Like, we need something that lasts for a long time, something that's passive, so that it doesn't require the human element in the interaction, which can modify the effect.
Yeah.
And of course it doesn't require energy use. It's got waterproofing properties, so that's a co-benefit. And it can also kind of minimize the sound that comes into the building.
Oh, right, of course, because if you have a tin roof that's quite clacky with the rain, so that kind of softens the sound on top. That makes sense.
But actually, one of the great things about the cool roof is it reduces your energy demand and your active energy use. So that's why actually in a lot of high-rise structures around the world, they actually have a cool roof on top.
Oh, wow. I didn't even know that.
Yeah, let's go on a roof tour.
So this I guess technology, you call it, is being serviced in these rural areas, but it's also being used globally in urban settings as well. Yeah,
of course it is, yes. Actually, so my first sighting of cool roofs was over the kind of buildings in Cambridge in the US, in Boston.
Oh.
Yeah.
Yeah, so it would make sense for like a certified green building or something like that to try and passively mitigate some of the heat to cool their buildings. This makes a lot of sense. What was your plan for studying the impact of these cool roofs? I know it was a randomized control trial. So what exactly was your intervention, and what were you trying to find out?
So our intervention was to apply the cool roof, and we took a sample of 600 households. And the beauty of using the randomization is that we're avoiding, selection bias.
Right.
And so then we can really say that this is a causal study. We're able to say that it's the cool roof that's actually causing the observed effects that we see.
Right. This kind of randomized control trial is normally done for medical interventions, right? So was it significant that you were taking this approach to study a new roof installation?
Yeah, well, for us, it's about using the best science and the methods that are available. And then using it for the purpose that we need, which is right now to test solutions to combat the effects, or at least to adapt to the effects of climate change. And in a way, if you can combat it too and mitigate, your emissions, that's great, which is what a cool roof hopefully will allow us to look at. So does having a cool roof mean that you have better health, environmental and economic outcomes? And health there for us is the key thing, because we want to make health and people's well-being and comfort the center point of everything. It's a powerful way to drive a message of how something works or not.
So tell me more about how you partnered with the local community and organizations.
Our research institute at Heidelberg's had a long-standing partnership with Dr Alisha and the Nuna Health Research Centre. They cater for about 110,000 inhabitants around Nuna. And the people that are in all the villages where we do the study. There's a health centre that is responsible for providing care for the people there. And at the same time, since 1992, Ali and the team have set up a health and demographic surveillance system. And basically what that does is it captures important demographic and health information about the population, the births, the deaths, marriages, people leaving the community, in and out migration. It also looks at the actual causes of death, because without that we don't actually know what the health status is and what the trends are, right? Wow. Data speaks. And so it's because we've had that data and that infrastructure that we're able to go in and do some really cool studies in an area like that. And they've also collected weather data.
Oh, that's helpful. Yeah.
Yes, through local weather stations. So this kind of infrastructure and their partnership with the community in prior studies and trials has really helped us and given us a platform to do our own work in. Yeah.
Hello, I'm Julia Gillard, Chair of Wellcome. Thanks for listening to our podcast, When Science Finds a Way. Wellcome supports researchers around the world to make discoveries and help solve urgent health challenges. We believe in the power of science to build a healthier future and the need for inclusive, collaborative action to ensure everyone can benefit. To get involved, visit wellcome.org, that's welcome with 2 L's. Now, back to the story.
Let's hear from Dr Guillame Compoare, who was a field coordinator in this study. He spoke to us about how local communities were involved in conducting the research.
We go to the village and we meet in each village the key stakeholder. So the chief of the village, we meet them to have the permission to speak with the people in his village. And we explain the objective of the study, we explain the goal of the study. So we go throughout all the village to explain them what we want to do before starting the study. To set up my team, we use local personnel. If you want a study to run well, you have to choose people and to be connected with participants. Because local personnel, they know well the villages. They speak the local languages because we have many languages. So we selected our team locally to be sure they will be accepted in the village. For the cool roof application, our objective is we try to see if we can find locally the person. And we use a local paint and we train them to guide them, to show them how to mix the cool roof, how to do the cool roof. And we involved also the participant. To do the cool roof, we involve also the participant. First, they help to repair the roof before we come. The mud brick roof, if we didn't repair it, it is difficult to paint the roof. Also, the tin roof, they help to repair the earth before we are coming. See, if they didn't do it, it will be difficult for us. The benefit for working closely with participants is they will be involved. they will be happy to answer to your question because they are happy to give a contribution to this party. It's like you are in a family. Because we have sometimes sensitive information, if the participant is not close to you, they will not give you a good answer. So it's a good thing to be close to participant, to have what you want, to have the information to you want. At the end, you can reach your goal.
It sounds like your team put a lot of thought and effort into engaging communities as part of the study. When you come into a country as an outsider to conduct research, how important is it to make sure that research is locally owned like this is?
What we want is for this to pretty much be driven from the ground up, right? So we actually start off by doing a lot of formative work in the field. We do tons of community engagement. We go out and find out how heat is affecting people. We go and do focus group discussions and get them to talk to each other. That's pretty much how we started off. Mm-hmm. We met the community leaders, we met citizens, we took demonstration samples of cool roofs and showed it to them, got them to touch it, smell it, feel it, to say, well, what do you think of this? Will this be acceptable in your community? Is it culturally okay? Is white an okay color?
Right. All these little nuanced things that you wouldn't know unless you engage with the community.
The more we can empower the community and get them involved, and of course seek the permission from the elders in the community and do things in a culturally sensitive way. I think the better off we'll be.
Let's hear again from Gninasse Rose. She was one of the participants in the trial, and she told us about her experience taking part in it, as well as the impact it made on her life.
We had monthly visits when someone came to take our blood pressure and body temperature from our ears. They took our urine for observation and also took our blood. There's also a device that hangs from the roof of the house inside, which measures temperature. We didn't have any concerns because we know that installing the cooling roof will be beneficial to us. The benefits are there. It's cool in our houses, the temperature has gone down, our bodies don't heat up as much, malaria and frequent headaches have decreased. Before the cool roof was installed, I couldn't even sleep in the house, so I spent every night out in the heat. But now that the roof has been painted, I can sleep in it without any problem. We rarely shower now, and we sleep inside. We can be inside all the time, day and night. I hope everyone in the village will get one of these cool roofs, because it will be better for everyone.
As a researcher, how does it feel hearing something like that?
When we do these trials, we hope to, or when we bring a certain intervention into a community, we hope to create a small change to improve people's lives. Like, that's what it's all about, right? And this isn't an air conditioner, it's not.
Sure.
But the fact that we're seeing these types of responses and that the community feels this way, I'm really happy to hear it.
So, you mentioned the caveat, it's not an AC. So if we're talking about, 40 Celsius, 104 Fahrenheit, what would the average temperature reduction be on a hot day like that inside?
Indoors during the day, we're observing about a 1.2 degrees Celsius reduction in temperature on average across all homes. There's more of a cooling effect in tin homes, about 1.7 degrees Celsius. Mm-hmm. And so that's still quite significant because I think the human body is sensitive to temperature.
Yes, of course.
And so, I'm really, I'm thrilled to hear that, a small degree of change like that is making an effect in people's day-to-day well-being and comfort. And that's the beauty of population trials and studies, is that when you have an intervention that's creating a small effect, but across a large population, you actually see a shift.
Yes. So getting into the nuts and bolts of your research, what were the different things that you were measuring? And because it wasn't just physical health markers, right?
Yeah, that's right. There's multiple ways that the organ systems in someone's body reacts to heat exposure. So one of those is the way that our heart and the cardiovascular system reacts.
Okay, so like an increased heart rate if you're hot?
Yeah. So what happens is your body tries to cool down, right, when you're hot. And so you've got the blood flow being redirected from your core organs to the periphery and to the outside to kind of have this radiative cooling effect. And so your heart then has to pump the blood harder and faster.
Right, to cool the body.
To get the blood to the core organs.
Right.
Because you've got the blood going to the
surface. Right, okay.
And so there's that type of strain, and then you've got other things like a lot of sweating going on, and so you lose electrolytes and fluid. And so that also means that your heart has to work harder. And typically with heat, there's a range of different responses that kind of all contribute to placing more strain on the heart. So that's one of the organ systems, and that was actually our primary outcome that we sought to look for a relationship with. Indoor cooling. And how does it affect the heart rate? And then and then we also looked at a whole range of secondary outcomes.
Okay.
So objective measures like we were talking about, like blood pressure, markers of heat stress, so dehydration. We collected people's urine sample. We looked at also capturing a whole lot of subjective outcomes, like the softer things. We wanted to actually understand someone's sense of well-being and comfort. So we asked them a series of questions and captured their heat stress.
Okay.
It's like an index.
Yeah.
And then...
But a self-reported one.
That's right. And so then we're able to triangulate the results with the heat stress marker, for example, dehydration, and then with what they actually say with their level of heat stress, and we can, corroborate the results. So... that's a nice way of when you capture these objective and subjective outcomes together, it's a great way of being able to give an overall picture of what happens to somebody. And then we, of course, looked at things like sleep, productivity, mental health, so depression. We looked at intimate partner violence.
So who collected all of this data? How did you get your information?
Yeah, so our data was collected by the field teams. So these are our trained staff that go from home to home. And they've come up with very innovative ways to collect the data. So, for example, when we had the floods, they literally had to make makeshift boats.
Wow.
And put their animals in their data collection
wow.
And actually travel
That's
from village to
incredible.
work. Yes, and they had to sleep there many nights when they couldn't actually get out, and because it was raining so much. So there's a whole infrastructure and setup and a huge effort from the team on the ground in collecting all of these important data that we've managed to capture.
And the team is made up primarily of locals?
Yes, of course. So we have Guillame Compoare. Well, we've got Alisha, the director, Guillame, who is our designated lead, coordinating all the field team work. We have a data management team there in Nuna who kind of analyze the data as it comes in and do quick QC quality checks and things. And then we've got at least 10 to 15 staff that go from home to home throughout the 2 years that have been doing a lot of the legwork and the groundwork.
I just want to say, anyone who is like, this is challenging, I don't know if we can do this, I will refer them to you. Because that's impressive. Oh my gosh.
Thank you. I'll convey your message to our field team.
Please do. Wow. So I know the results are currently being peer reviewed, but can you give us a broad insight into all the kinds of results that you saw, because you did take a lot of data. So
Yeah. So like I said, the primary indicator or outcome that we were interested in was heart rate. And here we're seeing a significant reduction in the number of beats per minute in the population, by about between 1 and 2 beats per minute. However, the very interesting thing for us is that this is actually a super healthy population of people with very low disease prevalence and other issues. So if they have a very healthy range of heart rate, say around 60 to 65, if you're reducing that by 2 beats per minute, it's actually creating quite a large impact on their...
Yeah, of course.
And remember that our heart works throughout our lives.
Constantly, yeah.
So if you're reducing that small burden on your heart, it's actually creating a large difference. And that's the same story with a lot of these public health things that we talk about. You reduce your salt intake by a little bit, and individually you'll reduce your blood pressure by a little bit, but across the population you're creating like a huge shift. So we're reducing the indoor temperature by a bit and subsequently the heart rate by a bit, but across the population you're creating a large change. And that's the beauty of population health.
Wow. And so in addition to heart rate, what else did you discover?
Yeah, so we saw a reduction jointly also with blood pressure. There's a trend of reducing blood pressure. We saw that the inner ear temperature was significantly reduced.
Wow.
We saw that we measured people's blood glucose, and that actually, there was a significant reduction there too, especially in males.
Wow.
And sorry, just coming back to heart rate again, we saw that there was more of an effect in elderly and people with tin homes.
And to touch on the mental side as well, what did you discover there?
Yes. So we saw we saw that there was a reduced kind of depression score in people with cool roof homes. And so you're having the benefits. Like our human body isn't something that works in isolation. The organs all play into each other and the systems. And so it's a really nice story overall that we're seeing these general reductions in almost all the outcomes really. Intimate partner violence was an interesting one. So we found that there was a 10% prevalence in physical intimate partner violence in the population, which didn't include verbal violence or anything like that. Which is quite high if we have a sample of 1,200 participants,
Yeah.
And so, giving them a cool roof significantly reduced the IPV, intimate partner violence, in the community.
Wow. That's incredible. And I really appreciate your explaining how all of these small incremental things, if you're impacting hundreds of people in a community, you are creating a larger shift that is much more noticeable than maybe something to an individual person. I think that's really interesting. Now, your team is in the process of expanding the Cool Roof trials to other locations. Tell me more about where you'll be working.
We're now going to be extending this Cool Roof trial from Nuna to 4 climate hotspots around the world.
Wow.
So we've kind of selected strategically the spots, 1 in each continent.
Okay.
So in Latin America, we'll be working in Hermosillo in Mexico. And in Africa, we'll be going to urban Burkina Faso to Ouagadougou.
Okay, cool.
We're working in the Pacific Islands in Niue Island.
Oh, wow.
And the last site is for Asia is in India in Ahmedabad, where there's been devastating impacts of heat. And my colleagues have just told me that it's been about 50 degrees Celsius there this week.
Oh, my goodness. Wow. The benefits there, I'm sure, will be drastic.
Yeah, so we're working in informal settlements, slum households there. That's kind of one of the aspects of extending our work from what we're currently doing. And then we've also received funding from the German Science Foundation to now develop a package of interventions in Nuna. And here we're considering local vernacular architecture and, so things like local materials, what's available for us to take and to kind of enhance the cooling effect. So can we use the cool roof in combination with other passive cooling interventions, maybe better shading, maybe a indoor ceiling to break the heat transfer inside.
Right.
And then also perhaps improved ventilation and passive airflow inside the house. So we're exploring all of these different options now through design and simulation work, and then we'll be working with local community to co-develop the solutions and to develop a full package. As you said in your intro, we're all experiencing heat and we'll be experiencing it more in the future.
Yep.
So I only see that there's going to be more need for passive cooling solutions. And I think that our moment is kind of now to step up and to take this challenge on and to just address it. So we've shown that we can, partner with industry and in a responsible way and bring the solutions to the people most in need. That's what we need to do. I think that science has to be the driving force here.
Right.
We have to show that there are benefits and that the technologies that we want to take really do offer benefits, and they can be for reducing temperature, they can be for whatever purpose, but it has to be scientifically driven and through data.
Dr. Aditi Bunker, thank you so much for joining me again in Los Angeles in person. It's so nice to have you here and to share your results.
Thank you.
Thanks for watching this episode of When Science Finds a Way with me, Alisha Wainwright. I also want to say a huge thanks to all our contributors. When Science Finds a Way is brought to you by Wellcome, a charitable foundation that supports the global scientific community, working to build a healthier future for everyone. If you visit wellcome.org/podcast, that's welcome with 2 L's, you'll find transcripts from the show and a whole host of information about the urgent health challenges Wellcome is tackling. And remember to hit the subscribe button here on YouTube for more episodes of the podcast. See you next time.